So hello friends, and in this video, as in the last video, we saw that okay, if we want to find that if a number, like if we want to transform a number, so we checked like how many set bit it had. But actually, if we had the representation of a number and we want to count the number of set bits, so how will we count? So although if you are using C++, then there is a built-in function called built-in pop count, and whensoever you need to find actual number of set bits in a number, I will recommend you to use that inbuilt function, right? So, but the method which we are going to see here are not used to actually find the number of set bits, but they in whole will be used somewhere else to write some bigger program, right? So yeah, it is important to study for that case. So the first method is like if I have a number, right? Let's take number 5. Okay, so it can be represented as 101, right? So if anyhow I can extract the last bit, then what I will do is that I suppose if I had this one, okay, so then I will check for 10, then I will check for 1, then okay, I will check for nothing, empty. So what I will do is that I will check if the last bit which I have is 1, then I will increase my variable called count by 1. Suppose I will have a variable called count, okay, and I will initially it will have be 0. So I will do AND with 1, because see, in the last video I also told that if we want to see that our number has the last bit set or not, then we do AND with 1, right? If we do AND with 1, we get to know one thing also, that the number is odd for that case. Okay, we are not using the odd property, but we are using the property that the last bit is 1. I will get to know about it. So I had this number, suppose it is n. I will do n and 1. So if it is 1, then I will check, okay, the last bit is set. Okay, so the last bit is set, I will increase my count. Okay, it will be 1. Now I don't need this one anymore, so either I can find the last set bit. I should like by the formula of n minus n, and I should reverse the whole thing, and then I will should do the AND again with this. But it's a pretty lengthy procedure, right? And actually I don't bother about this last set bit, right? It is not of any use to me, right? So what I will do is that I will just do a right shift. Now in like bitwise, there is two most important thing called right shift and left shift. So in a right shift, as the word itself says, right shift the bits to right. If I have these bits, then I will shift these bits to right. So 101, it will be shifted right. So the space is only this, and I've shifted all the bits. So the last bit will be lost. It will be truncated, or you can say, right? So as we can see that by shifting right, we are reducing its value by half, right? So it is also said that by right shift, our value is divided by 2, right? Now if I say about left shift, then in left shift what we have is, suppose I have 101 and I have spaced this much. If I left shift this, then I will obtain 101 and the last will be remaining. So when it is remaining, we will place 0 automatically here. So as you can see that the number is now multiplied by 2. Okay, so the value is multiplied by 2. So it is the funda, you can say, method for left shift and right shift. So let me erase this. Yeah. So now you had 101, right? You had your 101. You will do right shift this so as to remove the last bit, because it is of no use, because you have already checked it if it is set or not, right? So you will have 10, right? Now you will say that the last bit is not set, it is 0, right? So you will not add anything in your count, but actually you have checked the last bit. So now you will further do a right shift and you will land on to 1. Now you have one bit and it is 1 and it is 1, right? We'll do and with 1 to check if it is 1 or not, and it is 1, so I will do simply, I will increase my count. Now as you can clearly see that when you again do right shift, so nothing will be remaining, it will be 0. So by this method you obtained the number of set bit it had. What you did was basically you run the loop to check all the bits. You check the last bit if it is set or not by doing AND with 1. If it is 1, then you increase the value of count. If it is not, then you don't increase the value of count. And either you do or you don't increase the value of count. You just did a right shift. By that right shift, you remove the last bit, and now you will check on the remaining these n minus 1 bits. Suppose the bits are n in that representation, so you will check on those n minus 1 bits, and then you will do the same procedure until all the bits are lost. So the time complexity of this would be O of number of bits, because actually you are checking all the bits. So let me clear the program and show you guys. Okay, so now we had a program. So it is the function which will count the number of set bits in it. Initially I will have my count as 0 because actually initially the variable will be 0, right? Then I will run the loop until my n is exhausted. Now the statement, the line here, it indicates that n and 1. So n and 1 will either result in 1 or it will result in 0. If it will result in 1, so I need to add 1 in my count. If it results in 0, then I need to add 0 in my count. So either you can do if else condition, right? Or what you can do is that I know that for 1 you need to add 1, for 0 you need to add 0. So instead of using an if else condition, you can simply add this number to your count, which will indicate that okay, for 1 I am adding 1, for 0 I am adding 0. And whatsoever I do, like if I do a count or not, but I will do my right shift. By right shift, my n becomes n by 2. So you should take care of that, because by that your last bit will be removed and you will work on the remaining bits. And until the loop is exhausted, I will run this loop, means until the n is exhausted basically, and then I will have my value of count. Now we will move on to the next method. So what is the next method? See, the next method is, now as we can above see that the complexity was number of bits. We can reduce it by only using O of number of set bits. Now you might say, Aryan, what's the, like, are they not same? So I will say no. How? See, if I had a number like 1 0 0 0 0 0 0 0 like as it, okay, then what would have happened that in the previous problem you would have chosen to check on all the bits, right? Okay, fine. But in this particular problem, what you will do is that at every iteration you will remove one set bit. Any random set bit, you will remove it. I'm not saying, like, see, in the last video I told how to extract the last set bit, but in this I'm saying that I will extract any random bit, but I will extract exactly one random bit. Now how to do that? So see, if I have a number, let's suppose 5, if I write it as 101, okay, then if anyhow I can do, like, I can reduce one, I will, if I minus one bit from it, so what I will write it as n minus 1, okay, so I will write it as 4, so it will be 100. Now as you can see that if I do AND with these numbers, so the remaining number which is obtained has one set bit lost in it. Now the basic intuition behind this problem is that if I have something like, suppose if I write as, if I have number as 10, so if I will write it as 1 0 1 0, right? And if I do minus 1 in this, which means n minus 1 basically, so I will do minus 1, so it is 0, so it will take 1 from its right, so it will something like this, it will become 1 0 0 1. So as you can see that until my first set bit is obtained, it will go and do that first set bit to 0, and with that help, what I will do is that I will obtain a number like this. So as you can see that earlier it was 1 0, now it had become 0 1. For better understanding, let us take another example, very random example, 1 0 1 1 0, right? When I will do n minus 1, then what I will do? I will do minus 1 here, so it will take from here, it will be 2, right? It's very fine. So it will become 1, it will become 0, it will 1 0 1. So as you can see that when I had this number, when I had and this, so here it was 1 0, here it is 0 1. So the last set bit which we had, which was becoming 1, it will be reduced back to 0 by doing AND of these two numbers. So when I will do the AND, so I will do 1 1 0 1 0 1 0 1. Now as you can see that 0 0. So as you can see that one set bit is removed from this, and the number you obtained here, it is your new n. Why new n? Because at every step you will try to reduce the set bits in that particular number n, and you will see, okay, what's the number remaining, and same you will do again, like you will do n minus 1. So as you can see that if you do minus 1, then it will be 0, it will be 2, so it will be 1, it will be 2, so it will be 1 1 0 0 1. When you will do AND with this of this, so let me write it here, so it will be 1 0 1 0 0 1 0 0 1 1, then you will obtain this particular number, right? So it is n again. So see, at every iteration you are removing, first you remove this, after that you removed this, now at last iteration you will remove this, because until and unless your one set bit is obtained, you will take that one and you will make other zeros as 1 and make the 1 here, which was the first occurrence of 1 which I received by moving from right to left. I will use that particular one to make it 0 and make others 1. So with that, you will have your 3 set bits by running only 3 loop, like your loop 3 times. So let me quickly write the code for you guys. So yeah, here is the code. As you can see that first of all you have the variable called count, then you will run the loop of n until my n is exhausted, right? Now I will increase the count whatsoever may be the reason, because I know for sure that my count will increase only when it has one set bit, and in each while loop iteration your one set bit will be lost. And then I will do n and n minus 1, then I will return my count because I have actually obtained my count. So it's all for this video. In next video we will see about the basic operations, or okay, let us teach in here because it's a short concept. So see, if I'm said to extract, let us write it below. If I say to extract the ith bit, so if I want to ask you, okay, Aryan, I want to know that if the ith bit is set or not. So how to do that term? So see, first of all, happy Raksha Bandhan, and today is Raksha Bandhan. So yeah. So to extract the ith bit, what we need to do? We need to make a mask. Now, what is mask? See, if we have a face, then to show the region what we want to show, we apply a mask on our face, right? By applying a mask, we only show the region what we want to show, which means the eyes, nose and mouth, right? So I will apply a mask on my bit representation. Now how? If I have a number, let's suppose 1 1 0 0 1 0 0 1, okay, and I want to extract, suppose if I name these bits as 0 1 2, 3, 4, 5, 6, 7. So the number in yellow represents that, okay, it is the third bit, it is the fourth bit, and so on and so forth, right? If I want to find about the third bit, now what I will do is that I will check. I will make a mask that, okay, I will make a mask so that only third bit is visible. So how can I do that? I will do my 1. I will have my 1 in my hand. I will do its left shift by I times. I is the location of the bit which we need to find if it is set or not. Now, why I choose 1 only? Because I know the property of and that and has, if I do and of two numbers with like A and B, if I and is 1, then it represents that both the numbers are like set, which means both the numbers are 1. And if both the numbers are 1, only then I know that and is 1. I will check my answer. Okay, my answer is 1. It means that the number I choose, B number, was 1. I took it here. As you can see, I took 1 for that particular reason. And the number above it, if the answer is 1, so it is for sure that the number is A. I represent it as A. It is set. If my answer is 0, I know my B was 1. So it is for sure that my A bit was 0. So by that particular mask, what I will do? I will do 1 left shift I, which means that I left shift my 1 by I times. So what I will obtain is that 1 and the rest will be 0, right? Other bits will automatically be 0. When the bits are not added, it is automatically 0. When I will do AND with these two numbers, which is 1 left shift I and A, then what I will obtain is 1 or 0. If I obtain 1, so the ith bit was set. If I obtain 0, so the ith bit is not set. Although it was a pretty easy concept, but you must know these small concept for, to think fastly and logically in a bigger problem. So I will quickly write the code and I'll walk you through it. So here, as you can see, that I wrote this. So n and 1 left shift I, as I showed you above also, that I will do n and 1 left shift I. It will either return me 1 or 0. If it return me 0, which means that if it is not equal to 0, then I will return 1, else I will return 0. Which means that if it is 1, I will return 1. If it is 0, I will return 0. But here it is not the case. Sorry, I spoke something wrong. It will not return 1 or 0. Okay, sorry, it is right. It will return 1 or 0. So if it is not 0, then I will return 1. And if it is 0, then I will basically return 0 because the ith bit was not set. Now, okay. Now you are like, if you want to know the ith bit is set or not, you will do it. But if I say, okay, if I had my ith bit whatsoever, like if it is set or not set, I want to make it not set. So what you will do? See, you will take the property of mask. How? As I took a number like 10110, like something, any number random, n. If I want to make this 1 to 0, which means that any number, if it is set or not, I need to make it not set. I will take a mask when that particular ith bit it is set. I will take a mask such that the ith bit is set. I will do something like this. I will obtain something like this, right? Now I want to make it not set. So I will take its complement, which means I will reverse all the bits of 1 left shift I. So what I will get is, I will get 1 1 1 1 1 0 1 1 1. By this number, if I will do AND with this particular number, I know for sure that my AND will have that particular bit as not set only. Why this happened? It happened because I transformed this 1 to 0. And by doing AND of 1 and 0, I will get what? I will get 0, definitely. And the other number will not be affected because I am doing AND of all the other numbers, remaining numbers, by 1 only. So any number like a and 1, it remains and a and 0, it becomes 0. So using the property of and this and property, we are reaching to a conclusion that we can do it like this. So I hope that you guys can write the same code like this. So I will leave it to you. Although it is a pretty easy thing, I hope that you can do it. So that's all for this video, and happy Raksha Bandhan. See you guys in the next video. Bye.